Welcome to Hello Unknown, a podcast exploring the hidden parts of the human experience. I'm Jonathan Wright. Today, the universe. This episode is a puzzle. It starts in 1823 with a man named Heinrich Olbers. Heinrich was kind of obsessed with the night sky. He had a room full of 19th century astronomical contraptions, 2 achromatic Doland refractors, a Schroeder reflector, a heliometer, and 3 comet seekers. He was an amateur astronomer, but also fairly brilliant. He made a number of discoveries, in large part because he was able to work out a simpler method for calculating the orbit of comets, and he did this at a time before anyone really understood what comets were. Heinrich had a theory about the universe. The theory, now called the Olbers paradox, is the beginning of our puzzle. It was, more or less, a logic exercise, and it proved, eventually, that the universe has a boundary in time or space. It's simple, though, confession, I oversimplify it here. The basic idea was this: if the universe is infinite, if there's no boundary, never beginning in time and never ending in space, then the stars should go on forever, stretching back and back, further and further away, on into infinity. If this were true, Olbers thought, then we shouldn't have a night sky. Here's the reason. Imagine a sky with infinite stars. Next, imagine that light from those stars has infinite time to reach us. That being true, our sky would be all stars. It would be a blinding white. So we know it takes time for light to reach us, but with infinite stars and infinite time, in theory, the light from that infinite number of stars would arrive here and we'd have no night sky. Olbers thought that, in this case, the brightness of the night sky would average out to approximately that of the surface of a typical star. In other words, the surface of our sun. Heinrich, like Newton before him, held the educated view at the time, that the universe was infinite. But he also saw, as we do, a night sky. So that's the paradox. An infinite universe and also a night sky. Olbers looked up and saw wide gaps of black, these great voids, telling him, well, he didn't know. It turned out the question, the paradox, that was the important part. Heinrich did his best to resolve the problem he'd uncovered. He came up with a new theory, that there was something blocking the light from reaching us, some mass of dust gathered in the night sky. But that, at best, was only half the answer. I remember sitting, one time, in the Queen Elizabeth Theatre here in Vancouver. I'd gone with my class, as a child, to listen to an orchestra play Star Wars songs. It was my dream. I was very excited. Think a grand concert hall, red folding seats, red carpet, a massive stage, and high domed ceilings, and paintings reminiscent of some Catholic church. I was staring at the ceiling when I felt it. Maybe some holdover from an earlier state of human evolution. I was listening to a Star Wars song, the Imperial March maybe, and I looked up and I felt this flip in my perspective. I felt this deep sense of terror as I was transported up to the dome ceiling, and I felt like I was falling through empty space. I've had that same feeling other times. Sure, sometimes it's spatial, looking outside at the stars, for example, just lying on the grass. That same flip of perspective, that same sense that there's nothing all that much that tethers me to the ground, that separates me from the infinite above. Explained away, my theater experience, vertigo with the stars, it's just an overactive imagination and a fear of heights. Okay, maybe. But the feeling also shows up in other circumstances. Moments of sort of passive introspection, when I stumble onto something just more than I can understand. Ideas or experiences that don't fit inside my cozy, narrow, day-to-day understanding of life. They don't fit, but that doesn't stop me from trying, obsessing about death or the size of the universe, problems which, no matter how hard I try, I won't ever resolve. It's then that I have my minor panic attack. I feel the flip and the vertigo. My heart starts to beat wildly, and again, I feel like I'm falling through empty space. The other half of the story comes long after Olber's death. By 1963, there were two theories about the origin of the universe. The first was that the universe was static. This was called the steady state theory, and the idea was that the universe effectively hung in space, unmoving, and would do so forever. The other theory, eventually disproving the steady state theory, was that the universe was rapidly expanding. The story, according to this theory, was that at one point the universe was infinitely dense, a beginning of sorts, and then, for whatever reason, it exploded outward. For a period of time, there was no evidence for it. It's hard to understand now, as the idea is almost universally accepted, but as with all big universe-altering ideas, it began with many doubters. The term we have for this theory, named after the explosion, from the point of infinite density, the Big Bang, it was actually coined by British astronomer Fred Hoyle in the late 1940s, dismissing the theory as ridiculous. But eventually, two scientists stumbled on the answer. So it's 1963. These two scientists, Arno Penzias and Robert Wilson, were experimenting with radio waves. They worked at Bell Labs in Holmdel, New Jersey. The company had set up a massive antenna that, because of the launch of a new satellite system shortly after its construction, effectively was now obsolete. It was a basically useless, extremely powerful antenna shaped like an elongated horizontal pyramid just sitting there. And for whatever reason, Bell Labs let Penzias and Wilson point the antenna up to hunt for signals from the Milky Way. When they turned their pyramid-shaped antenna to the night sky, they found something they weren't expecting. They thought they'd eliminated all possible sources of earthly interference, sifting out local radar and radio and eliminating the heat from the antenna itself by cooling it to a temperature near absolute zero. But still, there was this faint buzz. It was this annoying hiss that didn't go away. They were good scientists. They didn't jump to conclusions. They tested methodically. Their first hypothesis was an issue with the machine, so they checked that and found no problem. Then they wondered whether it might be interference with the mechanism, something from outside, specifically pigeon poo, but it was fine on that point too. They checked other options off the list, but they eventually realized that it couldn't be anything else. The static didn't come from Earth. It didn't come from the Milky Way either. They didn't know it at the time, but it was, in fact, exactly what the Big Bang theorists were looking for. A message from the beginning of time. There's more to the story after a quick break. There is apparently a very select subset of humans who do not require the same amount of sleep as the rest of us. Their non-scientific name is short sleepers, and among this illustrious group are Barack Obama, Elizabeth Holmes of Theranos infamy, Heinrich Olbers, our comet guy, and also my buddy Jared, who only seems to get 4 hours of sleep at night, and yet somehow remains functional. So, if you're a short sleeper, awake at night like Jared and wondering what to do with your extra 4 hours, I have an idea for you. You could text your friends about the Hello Unknown podcast. I promise there's nothing they want more than to receive a text from you at 2:27 a.m. saying, quote, "Check out this pod, winky face emoji, money emoji, money emoji." Thank you all for listening. Please spread the word. Now, back to the show. In the conquest of this area of knowledge, each answer leads to another question, and then another. In this case, okay, when was the beginning of time? They've estimated that now, by a variety of methods, with the answer being approximately 13.8 billion years ago, give or take. So, sure. But anyone, like me, with an ounce of curiosity and no scientific knowledge whatsoever, should now be frowning. Like, how can there be a beginning of time? What came before the beginning of time? Or is that a question as meaningless as the phrase, as I've heard it put, what's north of the North Pole? A meaningless question. The North Pole is the northiest. The beginning of time is the beginningest. And that's where my panic comes back in. It's like I'm on the ceiling of the Queen Elizabeth Theatre again. Why? I shout like my 4-year-old son. Why? 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 What came before that? And before that? And before that? It won't do to tell me, soothingly, that gravity creates time, and that in the singularity, that point of infinite density whence the universe sprang, in the singularity, the concept of time is meaningless. That doesn't satisfy me. My mind wants to rip open the box, to beat the game, to get a final answer to the forbidden question. What, outside of time apparently, caused it all in the first place? Even though I'm certain, very certain, that the many possible answers would only lead to more questions and more beginnings to discover. When I was 20 years old or so, my friend Robbie and I uncovered our own theory of the universe. It was at Kerner's Pub, I think, on the UBC campus. It looks now precisely nothing like the pub we frequented almost 20 years ago, playing shuffleboard and drinking nut brown ale from Dead Frog Brewing with the motto, "Nothing goes down like a cold dead frog." It was a suitable place for scientific theorizing, in my view. At that time, it was mediocre beer, hamburgers and fries, probably cooked from frozen, and a stained carpet. It was our home for our 3rd year of university. So here's the theory. The universe will end. The theory, it's fine, maybe. How we arrived there, perhaps not so rigorous. We were very much not physics students, or even science students for that matter. Robbie ended up majoring in history. I was in English, but that didn't stop us. We worked it out dialectically, Robbie and me, a little buzzed on Dead Frog, pushing forward through logic and past it in a haze of alcohol and undergraduate stridency to the conclusion that the universe must, at some point, have an ending. Robbie and I both remember aliens being involved somehow. I don't know. But the basic idea was that if the universe was infinite, having no end, then there is infinite possibility that time travel would be invented. Yes, our theory was based on time travel. Okay, so this being definitively true, just go with me for a moment. If there's infinite possibility of time travel being invented, we would have been visited already by time travelers. In fact, we would be visited constantly, infinitely. As we can plainly see, we are not being visited microsecond by tourists from the future with their equivalent of khaki shorts and bucket hats. So, conclusion, the universe is not infinite. Olbers, with his paradox, put a cap on space. Robbie and me, we put a cap on time. In an earlier episode from season 1, I shared a metaphor. It's the idea that life, as I experience it, is a series of rooms, each representing a sort of framework or worldview I use to approach life. So, the first room, it feels big and dark, and then I understand what's inside. Eventually, I'm lulled into believing this room, this philosophy, this understanding of the world, it's all there is. But then something happens, some new idea, some difficult life event, and the door opens, and now I'm in a new room, a bigger room, and it's dark and frightening again, and the pattern continues over and over. It's a metaphor of this sort of lonely war. It's just me, my own mind, and nothing else. This series of rooms, one after another, conquering and then moving on, and then conquering and moving on again. This Sisyphean, never-ending struggle against the unknown. It never really escapes the confines of my brain. It's just a metaphor. It explains how I approach the world, but says nothing about the world itself. Because the real world, it has only one room. Everyone and everything is in it. It's a room exactly as big as the universe. One way to look at this, the universe, is that I'll never figure it out. I'll never solve the puzzle. I'll never quite dominate this room as I did the rooms I constructed for myself as a child. In this view, there are answers, but there's always another question, and more of that vertigo of the infinite, when my lonely mind goes up into the darkness and I feel myself falling through the unknown. But there's another way to view this. The other way is the humble offering of the dead frog theory. Not what it uncovered, which isn't much, but what it serves. It shows the other way. It's a completely different posture. Not the lonely mind against the infinite, but two people, Robbie and me, together, having fun, asking questions and answering them, joining in with all those who came before us, and all those, including the armchair theorists with beers in hand, and the astronomers with achromatic Dolan refractors, and time-traveling tourists with Hawaiian shirts and SPF 50 on their noses, all of whom will join in themselves, following us when we're gone. It wasn't until decades after Heinrich Olbers died that his paradox found an answer. There were pieces missing for Heinrich. One of them was the nature of light, or rather, energy measurable to us as light. A static universe, fixed and hanging in the void, which Heinrich believed in, couldn't account for the energy of an explosive beginning of time. It was another paradox, very similar to Olbers, actually. In a static universe, the original energy from the Big Bang would be brighter to us than the light from any star, including the sun. Again, the evidence of our eyes tells us that's not the case. So, to work that out, a new theory, a new framework for viewing the universe was needed, namely a universe that's expanding. Proving the Big Bang theory required finding the presence of energy, this radiation. The energy was a remnant. It was the identifying fingerprint from the beginning of time, or close to it. It was a byproduct of the Big Bang, and the idea was that this energy would be spread across the universe evenly, including around our planet. So how would that energy look to us? In an expanding universe, the energy from the Big Bang, it stretches. The phenomenon is called redshift. Instead of an orb of light and heat, uniformly bright across the sky, the wavelength of the energy created at the beginning, at the Big Bang, is, for us, elongated into a different form of light altogether. Which brings us to the answer. It was that interference noticed by the two scientists working at the Bell Labs antenna in Holmdel, New Jersey. The response to the question asked by Olbers, why do we have a night sky? Why is there darkness between the stars? Was energy showing up as sound on an antenna. Not pigeon poop, nothing from Earth in fact, but the cosmic microwave background created by energy from the beginning of time. In 1978, Penzias and Wilson won the Nobel Prize for Physics. They didn't win the most important prize in science because of any theory they'd devised. The press release from the Royal Swedish Academy of Sciences made this clear. After stating that the measurements made by these men showed that the universe was filled uniformly with microwave radiation, it goes on to say, quote, "These two researchers made no suggestion about the origin of this mysterious radiation." What they did was join in. They engaged with the unknown. Like Olbers with his comets, with the help and knowledge and expertise of those that came before them, they discovered something strange and interesting, and they wondered what it might be. They were curious, and they had a look into the darkness of the infinite universe. Our episode today is written, edited, and produced by me, Jonathan Wright. Music is by Taylor Swindells of Neighborhood Libraries. Thanks to Emily Rogers, Matt Rogers, Matthew Lee, Jared Ing, Rebecca Wright, and Ian Wright. If you have questions or ideas for future episodes, you can email me at hellounknownpod@gmail.com or just write it in the podcast comments. And if you like what you heard today, please rate and review us on your favorite podcast platform because that is how more people get to hear us. And as a final note, this episode owes a debt to one of my favorite writers, the physicist Paul Davies. A couple years ago, I read his little book, What's Eating the Universe, over the course of like a day or two, and I instantly fell in love. I've now read almost every book he has written, for lay people at least. There's stories in this episode that are not about me, I originally discovered in his book. So if you found this episode interesting, you will find Paul's books just infinitely more so. I cannot recommend him enough. What's Eating the Universe is brilliant. Demon in the Machine is about how information is coded into biology, and the Goldilocks Enigma is kind of about aliens. So thanks, Paul. This episode is dedicated to you.